Thank you for your forbearance. Our next speaker is Mark Hudson. Mark is founder director of Coastway Limited. He's a chartered land, mineral and mining surveyor and geospatial engineer with the Royal Institution of Chartered Surveyors and the Society of Chartered Surveyors in Ireland. He's over 3 decades of experience in the geospatial engineering industry. Mark has given evidence as an expert witness in the High Court and provides court reports in relation to major construction litigation cases. He is also Managing Director of Subsurface Laser Scanning Limited and Director of Irish Legal Mapping Limited, both sister companies of Coastway. Mark is a regular commentator in the press and social media and speakers at conferences and seminars on geospatial engineering, laser scanning and building information modelling. Mark's presentation will demonstrate the key benefits of using the latest laser scan survey technology in conjunction with building information modelling for making accurate as-built records of existing buildings in need of modernisation and restoration. His presentation utilises case studies from Ireland and the UK. Additionally, the presentation will discuss the requirements for new build buildings designed in BIM to be as-built surveyed by laser scan surveys for purposes of creating permanent facilities management records.
Thanks very much there, Martin. Good afternoon, ladies and gentlemen. Thanks for the introduction there. Quite a long one, but yeah, at Coastway we do quite a lot regarding laser scan surveying and with building information modelling and bringing it over to digital 3D deliverables. So just a little bit about us, Coastway, an Irish company, myself from the UK, but I moved over here about 14 years ago. And that's basically what we do in a nutshell, set up in 1999. Laser scanning will be a big part of Coastway's business. Laser scan to BIM, high definition laser scanning. I'm sure quite a few of you will have come across laser scanning. What I'm going to try and demonstrate today is what we do with a laser scanner and how we transfer it into building information models, mainly through use of 3 case studies, both in the UK and in Ireland. Topographical surveying, geospatial engineering, that's a lot of what we do. So now just briefly what the presentation is going to be about, using laser scan technology in conjunction with building information modelling, very topical at the moment, especially in the UK. As a lot of you probably know, by 2016 all public projects are going to have to be designed and as built surveyed in a full complete building information model. Hasn't come into Ireland yet. I know there's a lot of people, myself I'm involved with the CETA BIM group as well, who's trying to get BIM as a standard in Ireland, but that's only going to happen if the government will listen. Now, to understand the advantages of building information modelling, I'm going to use a few case studies of where we've been involved right from the start, right through to the finish. House of St Barnabas in Soho, London, Royal Hospital Kilmainham, and an MSR building in Naas, County Kildare. Just sort of, a lot of it's all to do with building. We're involved with civil engineering as well, but I'm going to concentrate on the building aspect. And the presentation will highlight how we use the geospatial information from the laser scanner and put it into data that can be extracted from it. So I'm not sure if everybody's aware of what laser scanners are and what they can do, but I suppose to simplify it, you could think of it as a total station that's taking millions of points a second. We would set up a laser scanner in this room and we could survey this room in 2 minutes flat with millions of points. And each of those points would have a 3D east in northern elevation point on it. Very quickly we can model the data and put it into whatever deliverables needed afterwards. So just to show you some of the laser scanners that we actually use within Coastway to collect the laser scan data before we turn it into a BIM model. These are 3 of the laser scanners that we have. The one on the left is for a long-range laser scanner. We're actually using that one on a building that we started today, which probably a few of you will be familiar with. It's the Anglo building on the docks that hasn't got an as-built model of it. And they want a full as-built model of that building before the bank that's going to move into it. They want it turned into a Revit model. So we can use a long-range scanner up to about 200 meters away to collect the laser scan data. And then the other 2, the one in the middle and the one on the right, is a shorter range laser scanner that we use for inside buildings to collect the data. And that's the kind of specification that we'd get from each of these laser scanners, the 2 Leica laser scanners. 500,000 points per second from the top one, which is pretty rapid. Like I say, each of those points is a 3D point that we'll then use to put into a model. And the accuracy that we can attain as well. So we'll use these models to pass on to onto modelers. We do quite a bit of modeling ourselves, but you can create a very high quality and accurate model from which to do the design from. Mainly what we do at the moment is refurbishment work, working in schools, existing schools. We'll do a survey of an existing school, pass it on to the architects, and ideally they should be using this data into a BIM model, but they don't, and I'll come on to the reasons why. This is the advantages of using laser scan technology to rapidly collect data up to 2 millimeters of accuracy. You could take a point, we could scan within this room and measure from one point to another point to 2 millimeters accuracy, and we're obtaining that data within 2 minutes, very, very rapidly. And from that laser scan survey, we'll then generate an actual building information model where we put data into that model to make it intelligent, which is creating an actual BIM model. The additional information, we go around and we pick it up, positions of sprinklers, pipes, ductworks, extinguishers, whatever is it, lighting. For an example where we did a survey in Trinity College, there we did a full BIM model of a lecture theatre and put the intelligence information into the BIM model. So the architects and the designers can use that to develop the room if they needed to. So these are the advantages of where we see using laser scan technology to record this information, to create the model, which you then put the building information model information into. Complex geometry, surfaces. A lot of the old schools that we work on, they've got really complicated architecture. And the only way to pick up that intricate detail on the building is with a laser scanner. To pick it up with a normal total station would take you weeks to do, whereas we can do it in a matter of hours. We've got a high level of detail to be recorded. Congested tight fits. We've got a lot of buildings where we have to get into, and you can get in there with a scanner and tie it all down. And far away or difficult to access areas, like the Anglo building, we're able to survey the exterior of the building from a long distance, up to about 200 meters away, to 2 millimeters accuracy. Non-intrusiveness. We don't need to get into the buildings again. Lane closures for infrastructure work. Delicate surfaces. And short windows of opportunity to be able to get into some areas where we've only got a matter of hours to be able to get into. Working on the Bank of Ireland, you've only got a short spell of time to get in there to get the data that you need, and unsafe to occupy. So one case study I'm going to talk about is House of St Barnabas, Soho. We were asked to tender for a project in St Barnabas here, and it's to do with Crossrail. Crossrail is going directly underneath this building, just to the one side of Tottenham Court Road. They didn't have an as-built model of this particular building, and it's a very important building as well. So they wanted to have an as-built survey done of the building by laser scanning, and then put that into a building information model. And the reason they wanted that information was that if by any chance that when they were tunneling underneath this building, that some of the ornate plasterwork came off. It couldn't be replaced. It would be gone forever. A huge insurance claim coming in. So it's an insurance protection as well to get it, to rebuild it, and to re-engineer it should that plasterwork fall off. Now that's the level of detail that's on the actual fire surround there, and it's the same on the ceiling as well. But if that fell down, it couldn't be replaced, so they wanted an accurate as-built model of it and put into BIM. And that's the ceiling. So one of the specialist scanners that we used was a Faro arm that we could actually survey features of that plasterwork there up to 0.1 of a millimetre. And that's the kind of accuracy that they were looking for in this particular one. So the scanners that we had ourselves, we had to hire in a specialist one down to that degree of accuracy to reproduce what was there in case that ceiling fell down when they tunneled underneath it. And I'm sure a lot of you have come across buildings like this. We've worked with the OPW on quite a few buildings. The Royal Kilmainham Hospital building, the big main hall. It's built very similar to this, but out of paper mache. And the only way to survey it is with a laser scanner and with a probe like this to get in there to pick up the detail. Because what happens if it falls down? You can't replace it. You have to have a model so you can replace it. So once we've got the data, this is the process that we go through to from the point cloud to the scanner operator. Then we extract the data, export it. We can put it onto a big web file, huge files it can be, onto the client, and then onto the design team. And we can reproduce it in any format required. More often than not, it's a 3D CAD file. What's happening a lot nowadays, where we get involved, is 3D printing. So once we've picked up the actual intricate detail, we can reproduce it to whatever scale is required, one-to-one with 3D printing. And this is the only way that you can do it. They'd also looked at doing molds of the ceilings as well, but that means actually getting in contact with the surface. They didn't want us to get in contact with the surface, so this gets away from having to use molding. And this is happening more and more. And a lot of the buildings that we've been working with at the OPW here, a lot of buildings, because times are hard, new buildings are not being built. They're looking at refurbishing existing buildings. And this is the kind of information that they need to be able to refurbish the buildings. And that's the specification of the scan arm. So up to 0.001 of an inch accuracy, very fine detail. So we can produce a model surface from that laser scan. And sorry, if you had 3D glasses, you better see that in 3D. I haven't brought any with me today. And the cherubs on there. So these are actually unique features that can never be replaced. Onto a case that's a bit closer to home. Well, Hospital Kilmainham, where the OPW brought us in, and again they wanted an as-built survey of their existing building, so they could do some refurbishment work on it. So traditional surveys, we do a topographical survey of the building as a start, and then we'd use the laser scanner outside. So you can see, that's a good example of what we're getting. So on the right-hand side, that's a photograph of what it's like. On the left-hand side, that's what the actual scanner's picking up. So that is made up of millions and millions of points of 3D data information on that surface that we can then reproduce as a model and into BIM. And again, the same workflow there to produce a building information model. But from that building information model, from that survey, we can produce a traditional cross-section. This is what we've found, is that we'll produce a 3D model, and then the architect will come to us and said, that's great, we've got a 3D model, but can you give us a 2D elevation? Can you give us a 2D plan? And this is what we're finding more and more, is that we've got the 3D information, use the 3D information, use the 3D model information. Why go back to a 2D plan or a 2D elevation when you've got it in 3D, especially something as complicated as that? But we can produce it if you want a drawing. Now, where we've also used laser scan to BIM is to improve energy performance of buildings. We can use thermographic cameras on top of the laser scan data as well. So the structural engineers and the environmental engineers and the building engineers can see what's going off within the building. Now, this was up in the attic. So we did a laser scan survey of the attic there. Lots of beams and pipe works and ducting around there that we literally captured within 5 minutes of a scan, all picked up from one, and then we move the scanner to another position, scan it from another position, put it together, and we can create a complete 3D model of the attic. So that's a typical point cloud. It looks a bit of a mess, but we can then go back and extract that information from that laser scan survey. So this is where we're starting to create the BIM model from the laser scan survey. We've extracted the pipe work. So from the point cloud, millions of points around the actual pipe, we can then extrude a pipe, an as-built survey of the pipe that is going through that attic there. So this is where it's trying to put intelligent data within the actual BIM model that will then be passed on to the heating and ventilation engineers and the structural engineers. Building information modelling. So I suppose at the beginning, that's where we all started off, basic CAD on the left-hand side there, drawings, lines, arcs. That's what most of you would be familiar with in buildings. And then onto 2D and 3D. And then into BIM, which is where we are now, and eventually we're wanting to get onto IBIM. And we're talking about a complete project lifecycle management of the building. So for this room, for example, we'll do a complete survey of this and produce an as-built survey of it, put intelligence into the model, and then that will be then passed on to the facilities manager of the building. So he's got a model of his building. This is an existing building. The same goes with a brand new build as well. Once a building's finished, with the BIM regulations that are coming in the UK in 2016, you'll have to produce a complete as-built survey of the building, fully BIMmed up with information in there that's going to be passed on to the facilities manager for the life cycle of that building. And if any changes are made to it, that can be updated. So that's where we are with BIM in the UK. We need to look at, if we can, you do the same in Ireland as well, because if we don't, we're going to get left behind. You won't be, if you're not involved with building information modelling, you won't be able to tender for contracts in the UK, and it's as simple as that. So the sooner that it comes into Ireland, the better, because if you're not involved with it, you will get left behind. So what does BIM mean to us in Coastway? So basically, we look at the site analysis and decide what we're going to do with that building, because there's lots of things that we can do with that building. 3D scan, high resolution photography, record the asset information, and then thermal imagery as well. I've got an example of where we use a thermal camera to stitch on to the point cloud as well to give that information too. But we'll look at where we want to go with the modelling and what's the deliverable that the client wants at the end of the day. And this, the biggest part of our problem is getting the client to understand what he actually needs. We go to some architects sometimes, and like I say, we can give them a 3D model, but at the end of the day, they might just want a 2D plan or 2D elevation. So we'd be wasting our time giving a full fancy 3D model to him if that's what he wants. But you're losing out on so much data. And then round to the actual building deliverable, virtual. We're doing a lot of virtual fly-throughs of buildings where client wants to be able to get funding from the banks, and this is where he uses the fly-through of the survey that we've done to be able to try and convince the banks to give him money, to show them this is what it's like now, and the work that they'll do with the model as well, to get the money to build the project. And we're doing some work with NAMA at the moment. This is the reason that the Anglo building's come around, so we can do the survey of the actual building there to show them what they can do with it. So, who's driving BIM? There's a growing market for building information modelling, but like I say, it seems to be more so in the UK than it does in Ireland. I'm a member of the C2BIM group in Ireland, as quite a few people here are as well, and we're all trying our best to drive it forward, to let people know that buying into BIM is good, because it's been proved that you can save up to 20% on your build, on your actual build costs, which is huge. So if you've got a building, 100 million, you could save 20 million on build costs alone by using the right techniques. There's a couple of companies in Ireland that are actually using BIM. CISC would be one that's just looking at it now, and others are getting involved with it as well. CISC are using it on the extension of the Guinness brewery there in St James's Gate, and we're getting involved with that one on the BIM as-built final survey. So it is being used by a few companies, but not enough. And all you guys really need to get yourself familiar with BIM and push it forward as well, and join groups like C2BIM to push it through, because it's coming. Changes in legislation requirements, it's needed in Ireland. It's been pushed through in the UK. It gives high expectations of the client and a better certainty of cost, which is always a good thing. It improves communication by the collaborators. So this is what it's all about, BIM, as I'm sure you know, collaboration with all the parties, the QSs, the structural engineers, the architects, the designers, all coming together to work together. We expect higher standards of information and moving towards common standards of delivery so that everybody can use it. No point the structural engineer being able to use one part of it if the architect can't use part of it. It's all a single entity. There is a demand for life cycle analysis, which is where the FM, facilities managers, coming in, and increased capabilities of technology. So benefits of BIM, I'm sure quite a few have heard of this before. 7D, it's becoming more commonplace now. 2D, 3D is very you've known about that, but 4D, time scheduling, sequencing, cost estimation, where the QSs will come into it. Life cycle management of the building, and then the operations maintenance for the complete lifespan of the building. This is where 7D within BIM comes from, and this is where we plug in right at the beginning with the 3D model of either an existing building or a 3D model of an as-built survey of a brand new building. There you go. That's it. That's where you start from. Because as we all know, what's designed isn't what's always built, especially when it comes to accuracies. You take a measurement across here from a construction plan as for construction, and if it can't to a penny, it will be different from what's actually constructed. It could be 50 millimeters out, but that could make a big difference when you're trying to fit something in 2-3 years later. That's the as-built survey. That's a construction drawing that you'd use, but it's different to the as-built survey. So, all things like that come in. A lot of where BIM's used is for clash detection, where you're trying to put pipework through buildings, and you didn't know about another pipework on the other side of the wall, for example. This is why it's important for getting a good as-built survey to hand over. Applications for laser scan BIM. We'd use it a lot in heritage, archaeology, architecture and building, asset management and mapping. We're doing a big exercise there with the National Roads Authority for asset management of what they've got. Spent billions of pounds of taxpayers' money on building the roads and the bridges. Now they want asset management. They want to know what they've actually got there to maintain it, because they're not going to be building many more roads for a few years to come. So civil structures, rail and bridge data, we're doing a lot of that as well, existing assets there, because that's what you need to maintain. There's no point building all these new roads and bridges if you're not going to maintain them properly. Okay, so this is just this is a point cloud. For those that have not seen it before, this is at Trinity College there. So this, what you're seeing there, is a fly-through of point cloud data at Trinity College there. So this is in the foyer. So this is all made up of millions and millions of points of data. And then we take photographs as well, and we overlay the colour, and we match it onto every million points of data. So we get a good colour recognition of what's there. So it's not a photograph, that is a point cloud. And then we'll then use this point cloud data as a basis for the 3D model, and then we can go back in there and we can put in intelligence into that model to say what's in there. We've passed this information on to the acoustic engineers, to the building management facility engineers, who they can work with this data to improve the heating and ventilation, and we'll look at the thermographic overlay as well that we've done. Okay, let's move on to that one. And that's what we've produced. So from that point cloud data, we then produced this 3D model, and it's a BIM model as well, because it's got intelligence within there. You can see the lights that are in the ceiling there. Just run that one again. So you could go into the CAD model there, and each of those chairs, you can tell what the chair is, you can tell what the lights are, the output of the lights. It's a full BIM model. It was produced, it took us about 2 days to produce the full BIM model there. But the actual laser scan survey took 2 hours to do. It's as quick as that. And then using the thermal imaging camera, FLIR thermal imaging camera, we then went through the same building as well and produced a fly-through of the same auditorium as well. So this is what we can overlay. That we can now overlay lots of information, and the building facilities manager can see where the cold spots and the hot spots are. But from that data, we can extract cross sections, asymmetric views, lots of information from that data, and do modelling from that data as well. Some of you will probably, I think you do that here, use it, don't we? You use Revit. So this is what we do as well. I mean, we produce the point cloud data to go into various modelling packages. Revit is a typical package that you could use. It's not the only one that you could use, but it tends to be one that a lot of architects would use, but it's not the only one. Now this would be of interest to you. MSR building. Again, this is another survey that we carried out outside the building, through the building, and this is point cloud data. So this is the kind of quality you can get from very rapidly. Again, the survey throughout the building, outside and through, took us about 2 hours to survey, and all of that is 3D data that we can obtain very, very quickly. But once we've collected the actual laser scan data, we then want to go through the building, and we use an iPad we've got a mechanical engineer and an electrical engineer who go through the building, and on the iPad he can put the information in to what those RSJ beams are, what all the other facilities are within the building. Put that into the model to give it intelligence, which is what we're trying to do. That makes a full BIM model. And then the thermographic images as well, that you can see there on the left-hand side. You can see the hot spots and the cold spots. That's point cloud data. And that's just putting the information into the model to give it the intelligence. And this is where the QS would come in as well. You could put in all the data and put it into a spreadsheet so you can quickly gather the information. So this is a summary of the key benefits there for the laser scan BIM process. Basically, we're producing a 3D CAD model to be used by all of the experts there for collaboration within the BIM field. So we can use a ready-made purpose of design for retrofit or for future work. But the majority of work at the moment, like I say, is for retrofit of existing buildings. That's the biggest thing at the moment. Hopefully, as-built surveys of brand new buildings as we move on and things turn around in the economy and more money is being spent. Hopefully it will. And there's some more key benefits there of laser scan to BIM for our clients that we're working with. Okay, thanks very much.